Welcome all. Welcome to today's online class. Today we discuss the last part of UV visible spectroscopy. It is about calculation of lambda max of certain class of organic compounds based on some empirical rules that is called Woodward Fieser rules. Woodward and Fieser, they studied the electronic spectra of a large number of molecules and they formulated some empirical rules. It's an additive rule. We should have some basic data with us so that we can calculate lambda max of any compound. Let us first of all, we have two classes of compounds. One is calculation of lambda max of conjugated dienes, and the second one is calculation of lambda max of alpha beta unsaturated carbonyl compounds, or simply we call enones. With respect to enones, we have to discuss what is the role of solvent in lambda max or solvent effect. Let us first go into the calculation of lambda max of conjugated dienes. Remember, in both the cases, we are concerned with pi to pi star transition. That means lambda max of pi star transition, because it is most noticeable peak, most intense peak. Okay. Now, in the calculation, there are two parts. First, we should fix what is the base value of the given compound. If it is a cyclic or conjugated diene, open chain, or if it is cyclic, if it is a cyclic value, base value is 215 nanometer. If it is cyclic, there are two cases. It can be heteroannular. I will explain that. Heteroannular means if there are two rings, okay, like this, okay, and the conjugated double bonds are coming in two different rings like this. This is conjugation, correct? And it is the two double bonds are in two different rings. That is heteroannular, double bonds in different rings. In that case, the base value of lambda max to be taken is 215 nanometer. If it is homoannular, that means both the double bonds, the conjugated double bonds are in the same ring like this, okay, then it is called homoannular. Annular means ring. Homoannular diene, then the base value is higher. Notice that 253 nanometer. And if it is acyclic triene, suppose your compound is open chain, acyclic triene, conjugated, then we take 245 nanometer. These are the base values to be kept in mind. And then we add some increments based on various features. Increments. One, extended conjugation. Suppose in addition to these two double bonds, there is one more double bond coming here, which is in conjugation, right? Suppose it is here, it is not conjugation, it will not add to lambda max. But if a double bond comes in conjugation, extended conjugation, so that resonance will be working over all these carbons, right? Then we have to add 30 nanometer. Remember in the previous class, for ethylene, pi star transition, lambda max was 167 nanometer or so. And when it is butadiene, it increased to about 200. So generally it increases by 30 nanometer for every double bond. Exocyclic double bond, if it is there, we should add 5 nanometer. What is exocyclic double bond? Suppose there is a double bond coming like this here. This is called exocyclic double bond. A double bond come exo to the ring. Okay? Like this, or it comes like this. Okay. Then lastly, for alkyl substituent and ring residue, we should add 5 nanometer for ring residue. That means, suppose your compound is this one, Okay, homoannular diene. So this is the system, homoannular diene system. So this is a ring residue, like substituents. This is also ring residue, this is ring residue. So we have to add 5 nanometer for all these ring residues. Similarly, if it is an alkyl substituent, if it is coming like this, one methyl group is coming here, CH3, we should add 5 nanometer. So we will go to examples to understand these rules. Okay, we will practice examples, a few of them. Let us take first of all a very simple compound, the first one. Look at this, CH3, CH double bond, CH single bond, CH double bond, CH3. What is the name of this compound? It is 1, 2, 3, 4, 5, 6. So hexa 2, 4 diene. Okay, it's a conjugated system. It's very clear. So the diene part is this. This is the diene part. This is the parent compound, or we take the base value here. So what about the computation? First you should write the base value. Fix the base value. It is an acyclic diene. So acyclic diene. So that it is 217 nanometer base value. That is fixed. Now increments. What are the increments to be added? Here it is not cyclic, there is no extended conjugation. Only 2 double bonds are there, diene. There is no more conjugated double bond. And exocyclic double bond, because it is not cyclic, so it doesn't come. And the last one, alkyl substituent or ring residue. Here you can see on this carbon there is a methyl group. So this is one alkyl group and this is another alkyl group in the system. So there are 2 alkyl substitution on this system. So alkyl substituent, we have 2 into, for each one it is 5 nanometer. So it is 10. So adding all these, what is the value coming? 227 nanometer. If we compare this calculated value with the experimental value, you can find close agreement. The next example. Let us take another one for practice. Now we take a ring system, a cyclic compound. Okay. This is the compound. Calculate lambda max for this diene. So first of all we take the base value, fix the base value. To which one it belongs to? It is heteroannular diene, correct? Different rings. So the base value is 215, heteroannular. So it is 215 nanometer base value. Now increments. Increments, is there any extended conjugation? No, only 2 double bonds, only diene. So that is not applicable. Exocyclic double bond. Check the double bonds whether it is exocyclic or not. This double bond is not. You can see this double bond is to this ring, it is exocyclic. If a double bond comes like this to a ring, if the double bond comes like this anywhere, it is called exocyclic. So this double bond is exocyclic to this ring, so we have to add. So exocyclic double bond gives 5 nanometer added. And finally ring residue. No alkyl substituents, but ring residues are there. That means how you fix it? See, this is your system, conjugated diene, and you check this is one ring residue to this side, this is another ring residue, and this is another ring residue. So there are 3. So we can write ring residue. Ring residues, there are 3 into, for each one it is 5, So 15. So what is the total? It is 235 nanometer. Okay, that is the lambda max of this compound. Right? Let us discuss another example now. Next one is another ring system. Okay, fused rings, two rings are there, and these are the double bonds. Let us go for the calculation. What about the base value? Base value. So you may get puzzled here whether we take this as a homoannular or heteroannular. Both are applicable here. If you consider this part is heteroannular, if you consider this part it is homoannular. Always you take the larger value. So this is to be treated as a homoannular diene. Okay, homoannular. So what is the base value? Homoannular, it is larger, 253 nanometer. Then there is one more double bond which is extended. Extended double bond gives, see, one double bond is increasing the conjugation, right? So you know there is blue red shift. Okay, when conjugation increases there will be a red shift. That is the point. So increments now. Extended conjugation. Extended conjugation, it is adding 30 nanometer. Then next one, exocyclic double bond is there. Yes, this you can see, this is now the system. Okay, the whole thing including this extended conjugation. This double bond is exocyclic, only this one, not these two. So there is one exocyclic double bond. Exocyclic double bond, 5. Finally, ring residue. How many ring residues are there? Yes, let us check. Taking the whole system, this is one ring residue like a substituent, second one, third one, that's all. So there are 3. Again, 3 into 5 equal 15. What about the total value? 20, 50, it is 303. 303 nanometer is the lambda max for this die. Okay, so that's about calculation of lambda max of conjugated diene system. I am giving you 2 questions for practice. You do it as a homework. One is this one. This is a compound. Okay, this is a conjugated diene, and the second one, you have a bicyclic system and there are 3 double bonds. So you may get doubted whether this is to be treated, which is a base value. This is to be taken as acyclic because the double bonds are not in the ring. Here also you can take this as an acyclic system because both double bonds are not inside the ring. Okay, and this will be extended conjugation. And one more example, one more question for calculation of lambda max is this. There are 2 methyl groups here, CH3, and one here also. Suppose it is shown 1 methyl here also. Don't worry, this is not going to get added because substitution should be in this diene part or the conjugated part of the system. Okay. Now let us discuss about the next class of compound, that is alpha beta unsaturated carbonyl compounds. And here we should know the base value. Okay, I think we will discuss that part in the next class. So make this clear. How to calculate lambda max of a conjugated diene? Knowing the base value and increment values, we can just add and get lambda max. Alphabet unsaturated carbonyl compounds, how to calculate lambda max of enones, we will discuss in the next class. Practice these questions. Okay, thank you.